All right, so today we're diving deep into something super important for anyone aiming for like that senior software engineer role. Those tricky technical interviews
Yeah.
that really want to test you on how you approach system design.
Yeah.
We both know that at the senior level, those conversations often focus on like how all the pieces of a complex system
They do.
work together, right?
Absolutely.
So you need to show you can think architecturally,
Yes.
make those smart design choices, and like articulate your reasoning super clearly.
Right. It's about showing that you can think at that system level and not just about the individual components.
Exactly. So our mission today is to unpack a couple of core concepts that pop up all the time in these senior level interviews,
Okay.
specifically domain-driven design, or DDD for short,
Yeah.
and microservices architecture.
Got it.
Think of this as your crash course in understanding those fundamental ideas
Yeah.
that really drive a lot of modern distributed systems,
Absolutely.
So once you grasp these, you'll have a really strong foundation for discussing different system design options
Yes.
in your upcoming interviews.
Okay.
So let's jump right in. Let's start with this idea of bounded context.
Okay. So imagine you're drawing a circle
Okay.
around a very specific area of your business.
Right.
That circle, that's your bounded context in DDD.
Okay.
And inside that circle, you've got a very clear set of responsibilities.
Uh-huh.
But importantly, you're also choosing to hide the internal complexities from everything outside of that circle.
Oh, interesting.
It's all about presenting a well-defined set of functionalities to the rest of the system
Right.
without exposing how it all works under the hood.
So it's kind of like a divide and conquer strategy for your business domain
Exact.
to make these really complex systems easier to manage for the development teams.
That's a great way to put it.
Okay, cool. So let's bring back our Music Corp example.
Okay.
Our hypothetical company.
Hmm.
We could picture the warehouse operations and the finance department as like distinct bounded contexts, right?
No.
The warehouse is all about shipping those instruments and records, managing inventory, and even like optimizing their loading dock processes.
All right.
All those internal details, like what specific software they're using to track shipments,
Yeah.
that's really their own business.
That's their concern, exactly.
Finance, on the other hand, they're laser focused on things like processing payroll for all the employees and handling all the payment transactions.
Right.
They don't need to be slowed down by the minute-by-minute details of what's going on in the warehouse.
Exactly. Each context has its own priorities, its own internal logic that the other doesn't need to be burdened with.
Right. So within these bounded contexts, we have these things called aggregates, right?
Yes.
And some of them might need to be accessed from outside the context, while others stay strictly internal. How does this idea connect with the whole microservices architecture thing?
Okay. So a bounded context typically will contain one or more aggregates, and think of aggregates as the core concepts within that specific area.
Okay.
Some aggregates, they're going to need to interact with other parts of the system.
Right.
So they'll have very specific ways they can be accessed.
Got it.
Others are just for use inside that bounded context.
Okay.
Now, when we start to think about designing microservices, the boundaries of our services often line up very closely with these bounded contexts and the aggregates they contain.
So like if our warehouse is a bounded context,
Right.
could we break it down even further into even more specialized contexts?
Absolutely.
Yeah.
Larger, more complex domains can definitely have these nested bounded contexts.
Okay.
So our warehouse could be divided into even more focused areas like order fulfillment,
Right.
packing shipping orders,
Okay.
inventory management, keeping track of all the stock levels,
Got it.
and goods receiving, handling all those incoming shipments.
So we're getting really granular.
Right. And the advantage of starting with these bigger contexts and then breaking them down later is that you avoid over-engineering things too early on. You start manageable and refine as you learn more.
Okay, I like that approach. So we've got a good grasp on bounded contexts. Now let's really dig into these aggregates.
Okay.
What makes an aggregate in DDD?
So in DDD, an aggregate is a group of related objects that are treated as a single unit,
Okay.
especially when it comes to changing data.
Mm-hmm.
Think of them as representing key real-world business concepts.
Okay.
Good examples would be like an order in an e-commerce system,
Right.
an invoice in a billing system,
Got it.
or a stock item in our warehouse example.
Okay.
These aggregates, they usually have a life cycle.
Yeah.
They're created, they change state, and eventually they might be archived.
Right.
We can often model these life cycles as state machines,
Yeah.
which helps ensure that the transitions between states are valid and we keep our data integrity intact.
Makes sense.
Now, the decision of what exactly is an aggregate is super important.
Okay.
If you make them too small, you risk ending up with this anemic domain model where the logic is scattered all over the place.
Right.
But if you make them too large, you lose the benefits of modularity.
Okay.
So the key is to think about what data consistently changes together as a unit.
So in the MusiCorp example, our order aggregate
Yes.
would hold all the individual instruments and accessories the customer wants to buy, right?
Exactly.
Those individual line items only really make sense
Right.
within the context of that specific order.
Exactly. Those line items, they're encapsulated within the order.
Okay.
And a core principle here is that aggregates should be self-contained.
Okay.
All the code that manages how an order changes its state,
Yeah.
like adding an item, removing an item, calculating the total,
Uh-huh.
all of that should be grouped together with the data that makes up the order.
So it's all nicely bundled together.
Exactly. And as we talked about before, a single microservice is generally going to be responsible for managing one or more aggregates.
Okay, that makes sense. What about how these aggregates are related to each other,
Okay.
both when they're within the same microservice and when they're in different ones?
So within a single microservice, managing those relationships is usually pretty straightforward.
Okay.
If you're using a relational database, you might use foreign key relationships to make those connections.
Right.
The trickier part comes when you need relationships that span across different microservices.
Yeah, because now you've got these separate, independently deployable units.
Right.
They might even have their own separate databases.
Exactly.
How do you usually handle those cross-service relationships?
A common first approach is to just store the ID,
Okay.
the unique identifier of the related aggregate,
Uh-huh.
in the local database of the microservice that needs to reference it.
All right.
So, for example, our finance microservice might have a record of a payment,
Right.
and that record would include the ID of the customer who made that payment.
Right.
If finance needs more information about that customer, they'd have to make a separate API call to the customer microservice using that stored ID.
Okay, I see. So it's like a two-step process.
Right.
But you mentioned earlier that this way of doing things isn't very explicit. What are the downsides of that?
So something that interviewers might dig into is that the connection between that customer ID stored in the finance database and the actual customer aggregate living in that other service. It's kind of implicit
Okay.
to really get how that ID is being used and what that relationship actually means.
Yeah.
You'd probably have to go deep into the code of the finance microservice.
Right.
It would be way clearer and easier to maintain if that relationship was more obvious.
So it's like a hidden dependency?
Yeah, you could say that.
Okay. So what's a better, more explicit way to handle these cross-service relationships between aggregates?
One good technique is to use a URI,
Okay.
a uniform resource identifier,
Uh-huh.
like you would in a RESTful API. Instead of just saving a plain customer ID, you might store something like customers 141.
I see.
This immediately tells you that you're talking about a customer resource that lives in another service.
Okay.
And you can access it through that path.
Makes sense.
Even if your system isn't strictly REST-based,
Uh-huh.
you can use a similar pseudo-URI approach,
Okay.
like customer taught 141,
Right.
which clearly shows a reference to a customer with that ID.
So it's like a more structured way of representing that relationship.
Exactly. And it has a couple of advantages.
Okay, what are they?
First, it's much clearer for developers who are trying to understand the system.
Right.
And second, if you build tools that understand these URI patterns,
Yeah.
you can make integrating and retrieving data between services a lot smoother.
So it's like you're baking in more meaning and functionality.
Precisely. It makes those dependencies between services much more transparent.
That's a big win for maintainability.
Yeah, definitely.
Okay, so when you're initially designing your aggregates, what should guide those decisions?
It's absolutely crucial to be guided by how the actual users of the system think about things,
Okay.
their mental model of the business.
Right.
How do they naturally think about these core concepts and how they relate to each other in their day-to-day work?
So we're talking about really understanding the domain from the user's perspective.
Exactly. That should be your main guiding principle when you're designing.
That makes a lot of sense. Okay, so we've spent a good amount of time talking about bounded contexts and aggregates.
Yeah.
Two really important DDD concepts. Now let's see how these ideas actually translate into the architecture of microservices in a real system.
Right. So both aggregates
Mm-hmm.
and maybe even more directly bounded contexts
Yeah.
give us really natural boundaries for our microservices.
Okay.
They represent these cohesive units of functionality
Right.
with well-defined interfaces,
Makes sense.
making them great candidates for figuring out the scope and responsibilities of each service.
So an aggregate focuses on a single key domain concept
Right.
and all the data and behavior that goes with it,
Exactly.
while a bounded context is like a collection of related aggregates
Uh-huh.
that all work together in a specific area of the business.
Right.
So when you're starting to design a microservices system,
Yeah.
how do you usually go about mapping these DDD concepts to your actual services?
When you're first starting out, it's usually a good idea to aim for services that cover entire bounded contexts.
Okay.
This helps keep the number of services manageable in the beginning,
Right.
and it reduces the overall complexity of the system.
So start big and then break it down later if you need to.
Yeah, as your system grows and your understanding of the domain gets deeper,
Uh-huh.
you might choose to decompose those larger services into smaller, more specialized ones.
But you should avoid splitting a single aggregate across different microservices. Right?
That's really important.
Yeah.
One microservice can definitely handle multiple aggregates,
Okay.
especially if they're closely related and in the same bounded context.
Yeah.
But an individual aggregate, which needs to stay consistent as a unit,
Right.
should always be entirely managed by a single dedicated microservice.
That makes sense to ensure data integrity.
Exactly.
Now, you talked about breaking down larger services later on.
Yeah.
How do you do that without disrupting the other services that are using the original bigger service?
This is where the idea of information hiding comes back into play.
Okay.
A microservice that initially models a whole bounded context,
Right.
like our warehouse service,
Uh-huh.
could be split internally into smaller, more focused services,
Okay.
like a separate inventory service and a shipping service.
Right.
But from the point of view of other services that need to use the warehouse functionality,
Yeah.
the original API of that warehouse service stays the same.
So it's like an abstraction layer?
Exactly. The internal breakdown into smaller services becomes an implementation detail
Okay.
that's hidden from the other services that are using it.
I see. So they don't need to know about the internal changes.
Right. They just keep interacting with that higher level API.
And that probably makes testing a lot easier too, right?
Absolutely. If other services are only using that top-level warehouse API,
Yeah.
you don't have to create complex stubs for all those internal services during your integration tests.
So it simplifies the whole testing process.
Exactly. You might even choose to run more complete integration tests, where all the internal microservices within that warehouse-bounded context are actually running,
Okay.
but you're still mocking or stubbing out the services outside of that context that it depends on.
Got it.
Okay.
Okay, so this is giving us a really clear picture.
Good.
Now let's talk about those situations where you have important business concepts
Okay.
that seem to be relevant in multiple bounded contexts.
Right.
You used the customer example earlier.
Uh-huh.
How do we handle these so-called shared models in a microservices world?
This is a super common scenario in large systems.
Okay.
A core concept like customer might be needed in both the finance-bounded context.
Right, for billing and payments.
Exactly.
And in the warehouse context, for shipping addresses and stuff.
Right, for all those delivery details.
It's the same real-world person or organization,
Yes.
but the specific information about that customer
Uh-huh.
might be different in each context.
That's a key point.
So the finance system might have records of past invoices and credit card details,
Right.
while the warehouse system focuses on shipping address and contact info.
Exactly. It's the same core entity,
Yeah.
but different aspects are important in each domain.
And sometimes the name we use for that concept might even change between contexts
Yeah, that's true.
to better reflect its role in that specific domain.
Exactly.
Yeah.
So in finance, we'd probably stick with customer,
Right.
but in warehouse, we might call them a recipient
I see.
because that emphasizes their role in getting those shipments.
So even though each context stores information about this entity locally,
Uh-huh.
and the specific details might be different, we often still need to link these local representations back to a single global identity for that customer.
Right.
We need to make sure it's the same customer across the whole system.
Exactly. And this is where those URI-based referencing techniques we talked about before can be really helpful.
Oh, right. So both finance and warehouse could store a URI
Yeah.
that acts as a unique identifier for that customer, maybe pointing to a dedicated customer management service that holds the global ID.
That's one way to handle it. And another cool thing about these shared models
Okay, what's that?
is that you can choose to show or hide certain information based on what each bounded context needs.
Interesting.
So even if the core concept of a stock item is relevant to both warehouse and finance,
Yeah.
the warehouse system might keep track of very specific details internally,
Right.
like the exact shelf location of each item.
Okay.
But it will probably only share the total available quantity with finance.
Right, for things like inventory valuation.
Exactly.
So it's about giving each context just the information it needs.
Precisely. And that helps to prevent tight coupling between services.
And it reduces the risk of conflicts or unintended consequences.
Exactly. It's all about maintaining the autonomy and integrity of each context.
Okay, let's move on to this idea of ubiquitous language.
Right.
It sounds like this is mainly about improving communication within the team and with the business folks.
You got to issue a ubiquitous language in DDD is the principle that we should use the same terms and phrases
Okay.
in our code,
That's
our
right.
documentation,
Yeah.
our user stories,
Okay.
and in all our conversations with business experts and users
Right.
as those users use themselves when they talk about their work.
So it's about speaking the same language.
Exactly. The goal is to create a shared and clear understanding of the business domain
Uh-huh.
so that everyone is on the same page.
That makes sense.
Right.
So can you give us a real-world example of why this is so important?
Sure. I remember working at a bank
Okay.
on this really complex system for managing corporate liquidity.
Corporate liquidity.
Yeah, it was all about how corporations manage their cash flow and stuff.
Okay.
Our product owner, she was a real expert in all the financial instruments and processes involved.
Right.
And we'd have these super detailed discussions using specific terms like haircuts.
Haircuts.
Yeah, it refers to reducing the value of an asset for risk management purposes.
Okay.
And end-of-day sweeps,
End-of-day sweeps.
which is automatically moving funds at the end of the business day.
Got it. So very specific financial jargon.
Right. And these terms were really precise and important in her world.
Okay, but what was the problem?
The problem was our code didn't use any of that language.
Oh.
At some point, they had decided to use this super generic abstract data model,
Okay.
loosely based on some widely used banking model,
Uh-huh.
but it was way too general for what we were doing.
Right.
The idea was that this broad concept of an arrangement
Arrangement. Yeah.
could represent any banking operation, loans, securities, credit facilities, you name it.
So they were trying to be super flexible and reusable.
Right. But it totally backfired.
Okay, how so?
The data model had basically stripped away any real understanding of the actual business we were trying to automate.
Right.
We weren't building a generic banking app.
Wow.
We were building a specialized system for corporate liquidity management.
Right.
And because of that mismatch between the code and the business language,
Yeah.
we as developers were constantly having to translate the product owner's language into these vague code concepts.
I see.
Our business analysts were spending tons of time explaining the same things over and over again.
So it created a huge communication barrier.
Exactly.
So how did using a ubiquitous language help with this?
By bringing the actual real-world language into our code,
Okay.
using terms like haircut, end-of-day sweep, and other specific domain terms,
Yeah.
right, in our class names, method names, variable names,
Right.
everything became so much clearer.
Right.
When a developer saw a task described using the product owner's words,
Yeah.
they could immediately understand what it was supposed to do
Got it.
and the business logic behind it.
So it really bridged the gap between how the business understood things and how the code was written.
Exactly.
It sounds like establishing a ubiquitous language is as much about creating a shared understanding within the team as it is about the code itself.
That's a great way to put it. It's about making sure everyone is speaking the same language and working from the same mental model.
Okay, that makes a lot of sense. Now let's briefly touch on event storming.
Sure.
What is that, and how does it fit into this whole DDD and microservices picture?
Event storming is a really cool workshop technique
Okay.
that helps you quickly figure out and visualize the domain model of a business instead of the tech team just trying to interpret the business requirements on their own.
Right.
Event storming brings together everyone involved.
Okay.
Tech team domain experts, product owners, even end users sometimes.
Wow, that's a lot of people.
It is, but it's all about building that shared understanding from the ground up.
So it's like a big brainstorming session?
Yeah, you could say that.
Okay, so how does it actually work?
The core of it is identifying and documenting key domain events.
Domain events.
Yeah, these are the important things that happen in the system
Okay.
that the business cares about,
Right.
like order
Yeah.
placed,
Yeah,
payment received, shipment delayed, things like that.
got it.
You usually write these down on sticky notes.
Okay.
Then you figure out the commands,
Commands.
the user actions or system triggers that cause these events.
Right.
Then you start grouping related events and commands around potential aggregates.
Okay.
And finally, you group those aggregates together to define the boundaries of potential bounded contexts.
So it's a very visual and hands-on way to map out the business domain.
Exactly. Everyone gets involved.
And you identify the key entities and how they're related.
Right. It helps to see the underlying logic, the flow of information, and those important relationships.
And it can be used for both event-driven and request-response microservices architectures, right?
Exactly. The models you create can be valuable for both.
Okay, this has been a really insightful look into DDD.
Okay.
To wrap things up, can you summarize the main benefits of using these DDD principles for designing and understanding microservices?
Of course. Especially for someone prepping for those senior level technical interviews.
Right.
The concept of information hiding, which is central to bounded contexts,
Yeah.
leads to more stable and well-defined microservice boundaries.
Okay.
By clearly defining what's internal and external to a context, you make your microservices more resilient to internal changes and less tightly coupled.
Right, so it's good for the overall stability and maintainability of the system.
Exactly.
What's another key benefit?
The effort to establish a ubiquitous language within each context
Yeah.
provides a consistent vocabulary for defining your APIs and event formats.
Okay.
This clarity in communication is so important in these complex distributed systems.
Right. It prevents a lot of misunderstandings.
Exactly.
Okay, so we've got stability and clarity. What else?
By aligning your microservices with those bounded contexts,
Huh.
you get better isolation between your services,
Okay.
meaning changes in one part are less likely to cause problems elsewhere.
So faster and safer deployments.
Exactly.
Yeah. And lastly.
The biggest benefit of DDD in a microservices context
Yeah.
is that it keeps the business domain front and center in your design.
Okay.
This leads to a much deeper understanding and better communication between the tech teams and the business stakeholders.
Right.
And ultimately, it means you build software that actually meets the needs of the users.
It's all about building software that reflects the real-world business it's supposed to support.
Exactly.
This has been a really valuable discussion.
You're welcome.
So for our listeners out there who are preparing for those tough senior-level interviews,
Yeah.
understanding these DDD principles,
Right.
bounded contexts, aggregates, ubiquitous language, and how they map to microservices. It gives you a really powerful framework for tackling those complex system design questions.
Absolutely.
I'd encourage you to think about systems you're already familiar with,
Yeah.
maybe from your own work experience, and try to mentally map out how you define the bounded contexts in those systems.
Right.
What would be the key aggregates in each context?
Good question.
And how would those aggregates relate to each other?
It's a great exercise.
So here's a final thought for you to ponder.
Okay.
Take a complex system you know well.
Uh-huh.
How would you define the different bounded contexts within it?
Right.
What are the most important aggregates in each context?
Yeah.
And how do you think they interact and relate?
Good stuff.
Exploring these questions will not only make you understand these concepts better,
Sure.
but it'll also help you have more insightful and confident discussions in your next senior technical interview.
Absolutely.
Thanks for joining us on this deep dive.
It was my pleasure.
We'll see you next time.
See you then.